Hi everyone, welcome to my YouTube channel. Today I'm going to show you how to construct a DFA for a given language. I'll be citing from the book Introduction to Theory of Computation by Michael Sipser. DFA stands for Deterministic Automaton. And languages are considered regular if they can be recognized by some finite automaton. This definition of languages comes from page 40 of the book, and it means that for any regular language, we can construct an automaton that will be able to determine whether or not a string belongs in that language. An example of a language, LM3 is equal to W, and W is the empty string, epsilon, or ends in a 0. And the DFA for this language is also given, and this comes from page 38. Also, it's given earlier in the book that the alphabet of the language is 0 and 1. So now you have a language and you have a DFA. Let's say we weren't given DFA. How would I go about constructing a DFA for this language? First of all, it's very important to understand the language. The language is saying that it will accept any string if it is an empty string or if it ends in a 0. Remember that the alphabet of this language is 0, 1, okay? So the first step is to start with the start state. The start state is drawn as a circle with the arrow pointing towards it. And a circle is labeled on the inside here with Q and a subscript 1. Q1 is accepted. And to represent that, you would draw a double circle. Now the next step is to go through each alphabet and see which state it leads to. The first alphabet is 0. If your string consists only of 0, that means that it ends in 0, so it is accepted. In fact, if your string consists only of zeros, it is also accepted. So we're going to draw an arrow looping from Q1 back to Q1, like so. Next alphabet is 1. If there's a string that is 1, it cannot be accepted. We're going to draw an arrow from Q1 to another state, Q2. Here, Q2 is a rejected state, and this arrow represents a string that's equal to 1. Now from Q2, we go back through the alphabet, keeping in mind that any string coming out of Q2 will have a 1 in front of it. So now, if we have a 0 coming out of Q2, it could represent a string like 1, 0. And since 1, 0 ends in a 0, it is accepted by the language. So we'll draw an arrow going from Q2 to Q1. After that, we're going back to Q2. And we see what happens when we get a 1 coming out of Q2. 1, 1. Then it will not be accepted. So we'll draw an arrow looping from Q2 back to Q2. Now that we have gone through the alphabet for each of our states, we can come up with a string and see if it will correctly be accepted or rejected by our DFA. 0, 1, 0, 1, 1, 0. This string should be accepted because it ends in a 0. Now, if we trace the steps throughout DFA, we should end up in an accepting state. 0, 1, 0, 1, 1, 0. As you can see, this string does end up in an accepting state. Anyways, that's the end of this video. Thank you.